2.6 part 2, we're still graphing, but now we're going to look at another type of graph. So in this section, we're going to go over absolute value functions. So we know an absolute value is when we see these two bars here. What do absolute values do to a number? It makes it positive. So if we had the absolute value of 5, this would be 5. If we had the absolute value of -5, this would be positive 5. So absolute value makes it positive. An absolute value graph is V-shaped. So it's always, always, always going to be in the shape of a V. We're going to skip domain and range for now. But the most important thing here is that your graph is V-shaped. So now we're going to jump right into graphing it. So here we're given an absolute value function, the absolute value of 2 times x minus 4. To graph it, we're just going to plug in numbers for x and get numbers for y. So first we're going to plug in -2. So I kind of tried to make these notes a little bit neater for you guys, so we have a graph to actually graph it and a box to plug in our numbers. So we plug in -2 for x, so we have the absolute value of 2 times -2 minus 4. What is 2 times -2? 2 times -2? -4. What's the absolute value of -4? 4. So we have 4 minus 4, which is what? 0. So when we plug in -2, we get 0. So this is going to be a point in our graph. So let's go ahead and graph that. We're going to go to the left 2 and stay at 0, and we put a point there. Now we graph 0. So we have the absolute value of 2 times 0 minus 4. What's 2 times 0? 0. And what's the absolute value of 0? 0.
Did Jonathan Carnahan get on too?
Yes, he did.
Yes.
What's 0 minus 4?
-4.
-4. So what's our point here?
0, -4.
0, -4. So we're going to go to 0 and go down to 4. Put our point there. Next, we can plug in 2. So we have 2 times 2, the absolute value of that, minus 4. What's 2 times 2? So we have the absolute value of 4 minus 4. What's the absolute value of 4? 4. What's 4 minus 4? 0. So what's our point here? 2, 0. So we're going to go to our graph. We go to the right 2 and put a point at 0. Once we have 3 points on our graph, we know our absolute value graph is going to be the shape of a V, so we connect our point with a V, like that. So if our points are perfectly symmetrical, we can just go ahead and plot our points with a V. Sometimes it might be a little off, so we'll have to plug in more numbers, but this one we can get away with just plugging in 3 numbers and graphing it. So now we're done. This is our graph. Any questions here? Anytime you see an absolute value in your function, you know your graph is going to be in the shape of a V. Ready for the next example? Okay. So here, our function is the absolute value of x minus 2. So now we're going to plug in -3, 0, and 3. So it doesn't matter what numbers we plug in for x. we can just plug in any numbers and find points in our graph. So here we're going to plug in negative 3 minus 2. What's negative 3 minus 2? Negative 5. So we have the absolute value of negative 5, which is what? 5. So what's our point here? Negative 3, 5. So we go to the left 3 and go up 5, put a point there. Now we can plug in 0. So we have the absolute value of 0 minus 2. What's 0 minus 2? Negative 2. So what's the absolute value of negative 2? 2. So what's our point here? 0, 2. So we stay at 0 and go up 2. Now we can plug in 3. So we have 3 minus 2, which is what? 1. So the absolute value of 1 is 1. So we have 3, comma 1. We're going to go to the right 3 and go up 1. So we kind of see that these points here don't give us a perfect V. So we need to plug in more points to find which direction our V is going to go. So the most important part of the V is the very bottom of it. Because we want to see this type of shape. But right now we don't have that type of shape. We don't know what's going on. So what's another number we can plug in here? We can plug in 6. We want to plug in something in here in the middle so we know like what's going to be 2. So we just kind of want to get a better idea of what our graph is going to look like, so we just want to plug in more numbers in between. So we're going to plug in 2. So we have the absolute value of 2 minus 2, which is what? 0. So when we plug in 2, what's our point? What's our point here? 2, 0. So we go to the right 2 and stay at 0. What's another number we can plug in? 1. So we have 1 minus 2. What's 1 minus 2? Negative 1. What's the absolute value of negative 1? 1. So our point here is 1, 1. So we're going to go to the right 1 and go up 1. Once we have some type of symmetry going on here, so we see that this point is our very bottom, we can go ahead and connect our dots.
But Ms. Carter, can you go back to the one, or the one you did for the one?
So for absolute value graphs, all we're doing is plugging in numbers, finding the shape of our graph, and drawing the V. Ready for the next one?
Yes.
Okay. So here let's plug in negative 2 first. So we have negative, absolute value of negative 2, plus 1. What's the absolute value of negative 2? 2. So we still have that negative on the outside, so this is negative 2 plus 1. What's negative 2 plus 1? Negative 1. So when we plug in negative 2, we get negative 1. So our point is negative 2, negative 1. So we go to the left 2 and down 1, put our point there. Next we plug in 0. So we have negative, absolute value of 0, plus 1. What's the opposite value of 0? 0. And negative 0 is still just 0. So we got 1. So what's our point here? 0, 1. So we stay at 0 and go up 1. Next, what do we plug in? 2. So we have negative absolute value of 2 plus 1. What's the absolute value of 2? 2. But we still have that negative on the outside, so we keep it a negative 2. What's negative 2 plus 1? Negative 1. So what's our point here? 2, negative 1. So we're going to go to the right 2 and down 1. Do we have enough points to connect them with our v? Yep. So we're going to put our v through these points. So last one. We have the absolute value of negative 3x. So first we're going to plug in negative 2. So we have negative 3 times negative 2. What's negative 3 times negative 2? 6. What's the absolute value of 6? 6. So what's our first point here? Negative 2, 6. So we go to the left 2 and go up 6. Next we plug in 0. So we have the absolute value of negative 3 times 0. What's negative 3 times 0? 0. And the absolute value of 0? 0. So what's our point here? 0, 0. So we put our point at 0, 0. Alright, and last we're going to plug in 2. So we have negative 3 times 2. What's negative 3 times 2? Negative 6. And what's the absolute value of negative 6? 6. So what's our point here? 2, 6. So we go to the right 2 and up 6. Do we have enough points to connect them with a v? Yep. So we just connect our dots in the v shape.